All right, so I'm going to make a review video for my class. We were talking about probability, conditional probability, actually. So that's where we're going to start. And with a deck of cards, those are usually the most popular probability, conditional probability problems. But when we read this, we read the probability of A given B. And when we look at that, what we're looking for is the number of A's and B's over the condition we're going to put on the problem. Okay, so hopefully we can explain some of this and it'll clear it up, but this is what we're looking at. So the question is right here, and it's talking about what is the probability that an 8 is a red card. And I stopped there and I paused because that's the condition they're putting on. What is the probability that an 8 is a red card? So our condition is that we need to look at 8s, okay? And then our desired outcome is an 8 and is red, all right? So a standard deck of cards has 52 cards. You have ace through 10, and then jack, queen, king. And then you have the clubs, the spades, the hearts, and the diamonds. So a deck of cards is broken up into sets of 13 almost. And then you have red and black, and obviously 26 when you do that. So what we are looking at is we're looking at the 8s. And when we look at the 8s, let me change this color real quick. We look at the 8s, we're looking at this right here. Okay, so if we look at the number of, oops, I was going to write 8, but I want B because that's my condition I'm putting on it. The number of 8s, there's 4 of them. Okay, so 1, 2, 3, 4. There's an 8 of clubs, 8 of spades, 8 of hearts, 8 of diamonds. Now, with that, we are going to find out how many red 8s there are. And if you look, there's 2 that are red and also an 8. So when we put that in our probability function, so A and B, so the number of A's and B's, so 8s and red, there are 2 of them out of the 4 8s total. And if we simplify that fraction, 1 times 2 gives us 2, 2 times 2 gives us 4, and the 2 on the top and bottom is what we call oneing them out because they create a 1, so they disappear, and it simplifies to 1/2. All right? Now, we take that 1/2 and we make it a decimal, 5 or 0.5. And when we move that decimal place 2 spots, we are going to get 50%. We'll change it to a percent. All right, so we have a fraction, we have our decimal, and then if we move it 2 spots to the right, we have our percentage. So the probability that an 8 is a red card. So if you pulled all the 8s out, you would have 4 cards, and you'd splay those 4 cards out, and somebody would draw one. They've got a 50-50 shot. They have 1 out of 2 shot of getting a red card. So that's pretty good odds. All right, so I had to change the program I used. So we are working with cleaning up some of this. Wonder, wow, I gotta erase. Sorry. Unfortunately, this is how we have to do it these days. So I'm going to put this up and then expand it out. And then we will move this one over. Okay, everybody can see that. Looks good. Make it a little bigger. Actually, we're filling this one in, so we'll make it a little really big. Hopefully we don't cover too much. And I should make my camera a little smaller. There. Okay. Let's move it down here. For the computer people, we'll see that. For everyone else, won't matter. All right. Number 2. So number 2, what is the probability that a red card, so once again, put a condition on it. It's a red card. That's our condition. Is even. So when we look at this, how many red cards are there? We talked about this before. There are 13 in each suit, and there are 2 red suits. There's hearts and there's diamonds. So that would give us 26 red cards. Okay? Now, we want a red card that is even. So 2 is an even number. 4 is an even number. 6 is an even number. 8 is an even number. And 10 is an even number. So those are our even numbers. So when we count this, we have 2, 4, 6, 8, 10 red even cards. All right. So now put the 10 on top over the 26 because that's our formula, the number of A's and B's over the number of B's. So we pulled this off the chart. We pulled the chart total off. We used the probability formula. We're going to substitute our numbers in. Now we want to simplify. So if I do 2 times 5 and then 2 times 13, the 2's will 1 each other out and we'll be left with 5 over 13. Now, quick math I don't have. So we're going to go to Desmos and we're going to put 5 over 13. And if you see that, it is 0.384. 384. So we're going to say this is 5/13 equals 0.384. If we move it 2 spots to our right to make it a percentage, we have 38.4%. So when we look at the probability of A given B, so what is the probability that an even card given that it's red? Okay, that's how you want to read it. So that line is what we call given. And anytime a problem tells you given information, that's a conditional probability problem. And then we could do equals 5/13. We could say equals 0.384, equals 38.4%. All those mean the same thing. Okay, so that is our second. Wish there was a clear all button, but I'll have to play with this more. My other one did not work at all. Usually I use whiteboard or whatever, and I couldn't, the pictures wouldn't come through. So I had to pivot, try something different, and this is what we're going for. Oh, delete. Okay. Which is fine. We pivot. We do what we do. Life of a teacher, let me tell you. All right. So, third one. We are looking for what is the probability that someone who didn't take medicine had no headache. Okay? So when we look at this, they're putting a condition on, and the condition is who didn't take medicine. So our condition is no meds. Okay? And with no meds, and we also want no headache. Ooh, can't read any of that. That's awful. No headache. Okay. All right, no headache. And no meds. So when we look at this, we want the number of people with no meds. So when we focus in, we're focusing in on the no med. Oh, let's undo that. Let's highlight that in the right color. Because we said people who didn't take medicine, we put in green. So I want to put this in green. Now, with no headache, though, now we're focused on these people right here. Because our condition has to be no medicine. So we can't use anything outside of that green box. That has to be in the green box. So when we look at this, what we want is no headache and no meds. That's going to be 22. And then no meds total is going to be 35. And if we put 22 over 35, if I were to simplify this, the only way to do the top is 2 times 11. And 2 times anything is going to be a decimal for 35. And 11 times anything is going to be a decimal for 35. So I know from my number sense that this is in simplest form. Now, convert it. 22 over, oops. 22 over 35. And if we look at this, change it to a fraction, you can see that it's the same fraction, so we can't simplify that. And we get 0.628. So we're going to just use that. So equals 628. Move the decimal 2 spots, and it becomes 62.8%. Okay? So that is the probability that someone who didn't take medicine had no headache. All right, moving on. Okay, and let's do ourselves a favor. We will get rid of this one. We will pull up this one. Oh, I really did like this one, because this one, if you understand the probability equation, then I think this one isn't as bad as people think it is. So we want our A and B. So they're talking about find the probability, and I always go to the last sentence. Anytime you're looking for a question in math, go to the last sentence. Usually you will find the question in the last sentence. And I didn't even read anything. I just have done so many math problems in my life. Usually that last sentence will tell you. So find the probability Lily passes her math test given that she studied. So we have to look at studied for our given, because that's what it says. It says given that she studied. So that's already telling us what our B is. And now we want to know pass and studied. Okay? So we want to know pass and studied. So there's multiple things going on here, but if we look at what they're looking for and what was given, the given is your B value. That's what that line, remember, given B. So B means that they studied. Pass and studied, that's going to be what our desired outcome is. So if we look at the number of pass and studied, so the probability that she studies and passes, they already tell us, is 17 over 20. They gave us that. Now we take the given information, she studied at a rate of 15 over 16. Okay? Now, I know there's fractions here, but it's okay. Fractions are our friends. So we're going to do 17 over 20 divided by 15 over 16. Now, if we want to do this longhand, we can. We can do 17 over 20 divided by, I'm going to make my divide a little bigger, 15 over 16. I was never taught how to divide fractions, but there's a trick. 17 over 20 multiplied by 16 over 15. So that's how we're going to do it. And we change it to 2 times 10 gives me 20, and 2 times 8 gives me 16. Then I can one out the 2's and do, well, we can do more, can't we? All right, we can do more. And you could rewrite it and look at that, but I'm trying to do this sort of this 4 times 4 gives me 16, and 4 times 5 gives me 20. Now we can do the same thing with the 4's and do 17 times 4 and then 5 times 15. So that will be 8, carry the 2, that will be 68. 5 times 5 is 25, that would be 75. 68 over 75. Now, you can believe me or not, but we have our handy dandy kit. Oh, not notebook. 17 over 20. Okay. Close that parenthesis. And then we can divide it and then do another parenthesis and do 15 divided by 16 and close that parenthesis. Okay. If we do that, we will get an answer out of 0.906 repeating. And if we look at that, it becomes 68 over 75, which is what we said at the very beginning. So the probability of A given B equals 68 over 75, which is equal to 0.906 repeating. 906 repeating, so I'm okay with that. Move it 2 spots to our right, and we're left with a 90.6% chance of passing, given that she studied. A lot of explanation in there, but don't get frazzled by fractions. Use a machine or get your number sent, start doing your multiplications, get that solidified. Fractions aren't difficult, they're just you don't do enough of them. The more you can do of them, the better off you're going to be. Okay? So, that gets us through number 4. Okay? So now let's look at number 5. Blow it up as much as we can. Okay, so a spinner with a dial marked as shown has spun once. Find the probability that it points to an even number. Oh, there's that word again. Given that it points to a shaded region. So, once again, we have some stuff going on here. Come on, pick the pen, please. Actually, let's do a marker. I don't like the marker. Maybe that would be bigger. So the probability of A given B equals the number of A and B's over the number of our conditions, B. So A and B equals even and shaded, okay? And then our B's are only talking about shaded. So if we do this, how many even and shaded numbers are there? Well, the shades are our lines. So we have a 2 and we have a 4. So there are 2 evens that are shaded, and there's 1, 2, 3, 4 that are shaded. So when we put that in, the probability of A given B equals 2 over 4. And we simplified this earlier, but let's do it again. The 2's 1 out, and I'm left with 1/2. So the probability of A given B is equal to 1/2, which is also equal to 0.5. Move it 2 spots, and that becomes a 50%. All right. Not too shabby. That one seemed pretty straightforward. Hopefully, the familiarity of these probability problems are just, I don't know, they do get a little repetitive because they keep giving you the same setup. And once you recognize that setup, that's where your money is going to be made. That's where you're going to start to really understand what these problems are asking. Okay? So, given the following information, the probability of D given E. Well, when we do that, remember, it's D and E over the second letter, which is E. Now, this is E and D over D. So, we have 2 situations going here. Now, D and E, where the D and E intersect, or where E and D intersect, is still the same thing. So whether you see D and E or E and D, it means the same thing. So this right here is telling us what the probability is for D and E. And instead of putting the number of times this happens, you could also put the probability that this happens. And it's the same formula, okay? So we can do the probabilities instead of counting the number of times that the situation happens. Another kind of typical probability thing that they do. So D and E is 0.15 over the probability of E, which is 0.2. Now, remember, this is the probability that D given E, okay? That's totally different than E given D, because look what happens. We still have a 0.15 on top, but what is the probability of D? That's 0.7. So those are going to be 2 different answers. I mean, we can convert them. We could do 15 over 20, simplify that. But let's let this do a little work for us for time's sake. And if you look at that, we get 0.75, which if you convert 75 cents goes in 3/4. So 3/4, which is equal to 0.75. Move the decimal 2 spots, and we're left with 75%. Oh, I did that on the wrong one. Apologies. Sorry. I won't make another mistake ever in my life. That's a lie. Okay, there we go. Now, oh, crap. Man, I'm just, can we back up to there? Okay, I want to erase this, not that. That was actually the right work. All right, now we need to do 0.15 over 0.7. So let's do 0.15 over 0.7. And we get 0.214. I don't know what that is. It's 3/14. So we'll go back here. We'll say it is 3/14. And as much as I think I have that memory, I don't. It is 0.214. If you do, you're awesome. 214. Move it 2 spots, and we're left with 21.4%. All right. So really, that was just manipulating the formula itself. I think it's a great type of problem, and it gets you to pay attention to what the formula actually is. So I really love this question. All right, on to our last two, which are Venn diagrams. So before we start this problem, I really want to chat a little bit about what a Venn diagram is. When we look at a Venn diagram, this circle right here. So our universe is the box. So hopefully, and especially when they give you percentages, if we were to add all these together, it better equal 100%. Because if you're dealing with percentages, everything's out of 100%. 99.9% of the time. There are some times where it's not 100%, but for the most part, usually you get 100%. So, if this is the case, we have 3 circles. We have die, haircut, and permanent. Okay? So, when we do this and they show a circle, okay, how many people requested a die? How many requested a haircut? How many requested a permanent? A permanent service. Okay. So this circle tells you how many people did this, but it also intersects with this one. So some people want a permanent service for a haircut. So that's what this little piece tells us. And now there's 35 people that just want a haircut, and then there's 30% of the people that want a haircut and a die. So that's where these intersections of a Venn diagram come from, all right? So that's just a little explanation on the Venn diagram. And I think it's important to talk about, though, because we are trying to find the probability. So it says find the probability that a randomly chosen client requested die given, there's our key word again, given they requested a permanent service. So that, I'm going to call it permanent. Call it P. Please don't get this. What should I do? PS maybe? Let's do PS. Permanent service. Okay. So what we need is we need the die and permanent service, so where these overlap, over the permanent service. Well, the permanent service is our blue circle. So if we do die and permanent service, or we just do the permanent service, we can see that this circle, remember the whole blue circle is permanent service. So if that's the case, that is 15%. I'm just going too quick. Now, where does the green circle intersect the blue circle? Does it happen in these types of problems? Well, take a look at this. When we look at a problem like this, do you see how green and blue do intersect? Yeah, but does it happen in this problem? It does not. So that means that there is zero intersection for these two things to happen. And now if we plug it into our formula, 0 divided by anything is going to come out 0. So there's no way to get a die, or at least no one requested a die and a permanent service together. They either wanted their die or they wanted a permanent service, but they never did them both together. And that's why you get this 0%. That one is a bit tricky, but I really like this problem. Miss Young did a great job picking these. All right, last one. And this one we will have an answer because I mean, we did these in class today, so that's why I know. All right, so the last one. Given that a randomly selected car has 2 doors, find the probability that the car has a sunroof. Okay, so look at this. They kind of cheated us a little bit, but what did they say right off the get? Given. Oh, so given that a car has 2 doors, this becomes our B value. So the B equals 2 doors. A and B together has to come from the problem still. But we know it has to have 2 doors and something else. Okay? Now, we haven't read anything else. All we have read is that it's given that we randomly select a car that has 2 doors. Find the probability that the car has a sunroof. Oh, so we're doing sunroof. Now, I could circle all of sunroof, but I'm only care about what is in the pink circle because the pink circle is our condition. And we have an 18. Oops, sorry about that. We have an 18 and we have a 0. So if I put those together, oh, I guess I should write sunroof and 2 doors. So I have A and B, when we put them together, becomes 18. 18 of these cars have sunroofs and 2 doors. But our total number of 2-door cars is 18, 0, 0, and 14. Well, the zeros, you will see numbers in these in other problems, but in this one, it's just 0, 0. So we have to put all 4 of these numbers together because these are all part of the pink, okay? So in other problems, if they're not zeros, you do have to include them in the 2-door, okay? But for the fact that they're zeros, we can sort of ignore them, or you could just write 18 plus 14 plus 0 plus 0 so that you get in the habit of not ignoring them or forgetting about them. And that becomes 32. So now when we do the probability of A given B, we're going to look for the number of A's and B's over just the number of B's. When we do that, we're going to put 18 over 32. 3 comes to mind. Let's just take a small number. 3 times 6 is 18. And then 3 doesn't work. Okay. Because 3 doesn't go into 32. How did you know that so fast? Because 3 divided by 3 is 1, and 2 divided by 3 you can't do. So I knew right away that 3 wasn't going to work. So let's do 2. 2 times 9, and then 2 times 16. Those are both workable. All right. So then I can 1 out the 2's, and I'm left with the probability of A given B comes into 9 over 16. Now, 9 over 16, I don't know. There's a lot of choices for these, but what's the only choice for 9? 3 times 3 is the only way to get 9 other than 1 times 9. But if we do 1 times 9, that's not going to cancel out anything unless there's a 9 in the bottom, and there's nothing 9 times what can give me 16, because we just used 9 times 2 to give me 18. So we have 2 times 8, we have 4 times 4, or we have 1 times 16. You can see none of those match, so 9 over 16 is our simplest form. So we're going to do 9 over 16. We can double check. Look, double check. See, our fractions are identical to each other. That means we have simplest form. 0.562. So we're going to say that this is 0.562. We'll move it 2 spots and get 56.2%. Man, thanks for coming on this journey with me. I hope probability gets a little easier for you as we move along and progress. Keep working it. And if you have questions, please feel free. Always going to plug joining the Math Dragon tutoring layer. Throw questions in here. I posted this one, and then I put a link in there for him so that he could go right to the video that explained his question. Okay, drag the puzzle. Thanks. And you can see I answered that question for him. I hope I'm not doing quiz problems for kids, but I just want to help people feel comfortable with the math that they're doing in their classroom. So please don't abuse me. I'm just here to help people out, understand math better. Don't cheat the system, because really at the end of the day, you're only cheating yourself. So have a blessed day, and if you ever need anything, please feel free to reach out. All right. Cleaning it up, and I'm out.